Picture this. You measure the distance from Sydney to Perth, about 3,300 kilometers, and your answer's off by less than the width of a single human hair. That's how accurate this physics theory is. And the bloke who invented it said, and I'm quoting him, "It's absurd." Richard Feynman built the most precise theory in all of science. Then he spent the rest of his life telling people it makes absolutely no sense. Here's what's mad about it. You can use this theory to predict nature to 12 decimal places. 12. That's like predicting the population of Australia down to a single person. But ask anyone, even Feynman himself, what it actually means, what's really going on underneath all the maths, and they'll look you dead in the eye and tell you, nobody has a clue. Stick around, because by the end of this video, you're gonna understand why the most successful theory in physics might also be the weirdest thing human beings have ever written down. G'day, welcome back to Curious Physics AU. I'm your guide through the strange, the beautiful, and occasionally the completely bonkers corners of physics. Today we are cracking open quantum electrodynamics, QED, Feynman's masterpiece. And by the end, you'll see why being accurate and actually understanding something are two very different things. Right. Let's start with why physicists go weak at the knees when you mention QED. There's this number called the magnetic moment of the electron. Don't stress about what it technically means. Just know it's a specific property of electrons we can measure in a lab. QED predicts this number. And when we actually measure it, the prediction and the experiment agree to about 1 part in a trillion. Let me put that in Aussie terms for you. Imagine you're measuring the distance from the MCG in Melbourne to the Sydney Opera House. That's roughly 880 kilometers. QED's level of accuracy would be like measuring that distance and getting it right to within the width of a strand of spider silk. Not a hair. Spider silk. Feynman himself put it this way. He said it's like measuring the distance from LA to New York accurate to the width of a single human hair. No other theory in all of science comes close. Not general relativity. Not the standard model of cosmology. Nothing. By the numbers, QED is the most successful scientific theory that human beings have ever written down. So naturally, you'd think, okay, we must understand what's going on. We nailed it. We figured nature out. Wrong. So wrong. Because here's where it gets weird. And I mean properly, stay up at night weird. Feynman's theory describes how light and matter interact. That's it. Sounds simple enough. But to make the numbers actually work, you have to accept some things that would get you laughed out of any normal conversation down at the pub. Thing number 1, light doesn't travel in straight lines. I know. You learnt about angles of incidence at school. Torches shine in beams. Lasers go dead straight. But according to QED, and this is Feynman being deadly serious, a photon traveling from your phone screen to your eyeball takes every possible path to get there. Every single path. It goes in a straight line. It also goes via the moon. It ducks through Bunnings on the way. It zigzags. It loops around Uluru. All at the same time. And then somehow, all these paths add up. Most of them cancel each other out. And what's left is what looks like a neat straight line from your phone to your eye. That's not a metaphor. That's the actual mathematics. Feynman called it the path integral, or the sum over histories, and it's the backbone of QED. Hang on. Gets weirder. Thing number 2, empty space isn't actually empty. What we call a vacuum, a box with nothing in it, is actually fizzing with particles popping into existence and vanishing again. Too quick to measure directly, but real enough to affect your calculations. Virtual particles, we call them. They're not really there, but you have to pretend they are. Otherwise, the numbers don't work. And thing number 3, particles don't have definite properties until you look at them. An electron isn't in a spot. It's in a smear of probabilities. And only when you measure it does it pick a spot. Before that, it's everywhere it could possibly be, all at once. Now, I reckon some of you are sitting there going, mate, this sounds like philosophy, not science. Made up nonsense. And that's exactly the problem Feynman kept slamming into his whole life. Feynman gave this famous set of lectures at UCLA in the 80s, which later became the book QED, The Strange Theory of Light and Matter. And right at the start, he says something you should tattoo on your brain. He says, and I'm paraphrasing a bit, I'm going to describe to you how nature is. And if you don't like it, that's going to get in the way of you understanding it. Physicists have learnt to shrug their shoulders. Nature does what she does. Our job isn't to decide whether it's reasonable. Our job is to describe it. Think about that for a sec. Every other bit of physics you've ever learnt tries to make sense of the world. Newton's apple makes sense. The reason your utes tires grip the road makes sense. Why the Earth goes round the sun makes sense. QED doesn't make sense. It just works. And here's the gut punch. Feynman, the man who built the theory, the guy who got the Nobel Prize for it, he flat out said, I think I can safely say that nobody understands quantum mechanics. Nobody. Not him. Not you. Not the sharpest physicist at ANU. Nobody. We can do the maths. We can predict the outcomes to 12 decimal places. But what's really happening? The story underneath? Haven't got a single clue. Right, here's the twist that I reckon is going to mess with your head. What if, and stay with me here, what if making sense is a human thing, not a nature thing? Think about it like this. Your brain evolved on the savannah. It evolved to dodge predators, chuck spears, remember which berries were poisonous. The world your brain is wired to understand is a world of medium-sized objects moving at medium-ish speeds. Rocks, rivers, other humans, dingoes. Your brain was never meant to handle electrons, or photons, or the fabric of space at the scale of a billionth of a meter. So when you say this doesn't make sense, what you're really saying is, my line-dodging brain can't picture this. And why would it? There's no evolutionary advantage to intuiting quantum field theory. Feynman understood this deeply. He used to say that at small scales, nature doesn't behave like particles, and it doesn't behave like waves. It behaves like something else entirely. Something we don't even have a word for, because we've never seen it with our naked eyes. So maybe the theory isn't absurd. Maybe we are. Maybe our whole idea of what making sense means is just built for monkeys throwing sticks, and QED is nature trying to show us a bigger picture through a keyhole. And here's where it gets properly philosophical. When you run the numbers and the predictions match experiment to 12 decimal places, you're not wrong. The theory can't be a fluke at that level of precision. So if QED is correct, and QED is also completely bananas by common sense, then the universe is bananas. And we are the weird ones for expecting it to feel familiar. Let me drive this home with the example that gets me every single time. You're reading a HSC Physics textbook or a VCE Unit 4 study guide, and it says, light is an electromagnetic wave. Then a few chapters later it says, light is made of particles called photons. And you're sitting there thinking, mate, which is it? Pick a lane. Feynman's answer is, neither. Light is not a wave. Light is not a particle. Those are just pictures your brain grabs onto because they're the closest things from everyday life. A thrown ball. A ripple in a pool. Light is something else. A quantum entity. And it obeys rules we can write down in equations but can't draw on paper. The double-slit experiment, you've probably seen a Veritasium video on it, is the cleanest example. Send electrons through two slits one at a time, and they build up an interference pattern on the back wall, like they went through both slits at once. But try to watch them do it. Stick a detector there, and they stop interfering. They go back to behaving like tiny little bullets. Why? Nobody knows. QED will tell you the exact probability of where each electron ends up. Spot on, every single time. But ask why watching changes the behavior, and physicists just shrug. That's the rule. Nature does it. Shut up and calculate, as the saying goes. And that right there is the heart of the theory. QED is a perfect predictor and a perfect mystery at the same time. The most successful theory in the history of science, built on foundations nobody can explain in plain English. Feynman spent his whole career staring into that gap. The gap between prediction and understanding. Between what the maths tells you and what your gut tells you. And his final word on it, the takeaway he wanted you to walk away with, was simple. Accept nature as she is. Absurd. That's the mantra. Not figure it out. Not force it to make sense. Accept it. Be stunned. Keep calculating. And never let your human intuition trick you into thinking you've got the universe sussed, because you haven't. Not even close. Here's what I love about QED though. It's humbling in the best possible way. We Aussies are actually pretty good at accepting hard truths. Weather can't be argued with. Tides don't care about your schedule. The surf's either there or it isn't. Feynman's message about physics is cut from exactly the same cloth. Nature is what she is. You don't argue. You watch, you measure, you write down the rules, and then you sit back, stunned that rules even exist in the first place. And maybe that's the real reason physics matters. Not because it gives us microwaves and mobile phones, although it does, but because it's the one subject where we sit down, humbled, and admit that the universe is stranger than anything we could have dreamt up. And that strangeness is on offer for anyone willing to sit with it. So next time someone tells you science is dry, or that we've figured everything out already, tell them about QED. Tell them we've got the most accurate theory in human history, and we still don't know what it's really saying. If this video made your brain tingle a bit, do us a massive favor, smash that like button, it genuinely helps the channel. Subscribe if you haven't already, because we are just getting started on this Feynman-inspired series, and you're not going to want to miss the next one. Comment below, what's the thing in physics that messes with your head the most? Quantum weirdness? The nature of time? Black holes? Drop it in the comments. I read every single one. Speaking of black holes, in the next video, we are diving headfirst into one. Literally, what actually happens when you fall into a black hole? Feynman style. No fluff. Just the hard truth that physics has cornered us into accepting. Cheers for hanging out. Stay curious, Australia.